Hi everyone, welcome to my channel. In this tutorial, we'll learn how to use the Principled shader in Blender. Let's get started. Add a cube object, add a subdivision surface modifier, set the subdivision level to 4. Right-click and make shade smooth. Hit the Z key to switch to render preview mode. Click the Render Properties tab and ensure that Cycles is active Render Engine. Set the maximum sample value to 32 for the viewport. Enable the denoise option. For lighting, go to the World Properties tab, click the Color node, and add an environment texture. I will share the download link in the video description. Go back to the Render Properties tab, scroll down to the Film panel, and enable the Transparent option, so the world background becomes transparent. Alright, let's add material for the sphere. Split the 3D viewport into 2 windows. Switch the viewport to the shader editor, and key to close the right panel. With the sphere selected, click the New button to add material. So the Principled shader node will be connected to the material output. The Principled BSDF combines multiple layers into a single easy-to-use node. It can model a wide variety of materials. The base layer is a mix between metal, diffuse, subsurface, and transmission components. There are also some input parameters in the Principled shader node. Base color is a fundamental parameter that defines the main color of the surface. It's sometimes referred to as Albedo. It represents the color of the material under standard lighting conditions without any shading, lighting, or reflective effects. We can select any base color by clicking on the color picker. We can also link a texture node to the base color input. Go to the Add menu and add a noise texture. Plug the factor node into the base color. Now we can see black and white parts on the surface. We can control the black and white parts. Add a color ramp node between the noise texture and Principled shader. Select the black color stop and drag it to the right side, so black parts will be highlighted on the surface. Let's switch the interpolation type to Constant. Select the white color stop and drag it to the left side. In this case, the black and white parts transition will be sharp. If you increase the scale value, you can have a smaller texture on the surface. You can change the colors. You can also add another color stop by clicking the plus icon. Alright, let's delete the noise texture and color ramp. We can link any image texture to the base color. Add an image texture and plug it into the base color. Open any image texture. To adjust the texture scale, select the image texture and press Ctrl-T. So the texture coordinates and mapping nodes will be added automatically. If it doesn't work, go to Edit menu Preferences, then the Add-ons tab. Find Node Wrangler and enable the add-on. Node Wrangler provides various tools that help you to work with nodes quickly and efficiently. Increase the X, Y, and Z scale values in the mapping node and adjust the texture size on the surface. Alright, let's delete the nodes and go over the other parameters of the Principled shader. The roughness value controls how smooth or rough the surface of the material appears. This value ranges from 0 to 1. If you set the roughness value to 0, the surface is completely smooth, resulting in sharp, clear reflections. This is typical for materials like polished glass, mirrors, or highly polished metals. If it is set to 1, the surface is very rough, scattering light in many directions and resulting in diffuse, blurry reflections. This is typical for materials like unpolished wood, matte plastics, or rough stone. We can also control which part of the material will be rough and smooth. Add a noise texture and color ramp. press Shift Control and left-click to view the texture. Switch the interpolation type to Constant. Select the white color ramp and drag it to the left side. We can also change the texture scale value. Plug the color node into the roughness node. Black parts are fully smooth and reflective, because the roughness value is 0. White parts are fully rough and non-reflective. The roughness value is 1. Let's unplug the noise texture. The metallic value determines how metallic or non-metallic a material appears. This value ranges from 0 to 1. To better see the metallic effect, lower the roughness value. If you set the metallic value to 1, the material behaves like a metal such as gold, silver, or iron. Metals have high reflectivity and tend to reflect their environment more sharply and specularly. We can also control which part of the material will be metallic and non-metallic. Plug the color node into the metallic node. Black parts are fully non-metallic, because the roughness value is 0. White parts are fully metallic. The roughness value is 1. Let's unplug the noise texture. The alpha value controls the transparency of the material. This parameter determines how opaque or transparent the material appears. If you set the alpha value to 0, the material becomes fully transparent. If it is set to 1, the material becomes fully opaque. In the same way, we can control which part will be transparent and opaque. You can watch the tutorial on how to make transparent material in Blender. The IOR, index of refraction, determines how much light bends when entering or exiting the material. This value is crucial for rendering realistic transparent and reflective materials. The IOR value is a physical property of materials and varies depending on the material's density and optical properties. Below you can see some IOR values for common materials. The purple normal input is used to modify the surface normals of a material, which influences how light interacts with the surface. This can create the illusion of surface details like bumps, grooves, and other textures without changing the actual geometry of the object. Let's add a bump node. Plug the color data into the height node and normal to normal node. As you can see, the material looks like it has bumps and dents on its surface. You can also use a normal map. Go to the Polyhaven website. Choose any texture. Download all textures in zip format. Extract the files. Go back to Blender. Add an image texture. Open the diffuse map we just downloaded. Plug the diffuse map into the base color. Set the metallic value to 0 and the roughness value to 0.5. Select the diffuse map and press Ctrl-T to add mapping and texture coordinates nodes. Increase the X, Y, and Z scale values. Add another image texture. Open the normal map we just downloaded. Switch the color space to non-color, because the normal maps use non-color data. Connect the vector to the vector node. Add a normal map node to convert the color data into the vector data. When we increase the normal map strength value, we can see the details on the surface. A normal map is a texture that makes a flat 3D model look like it has bumps and details without adding more polygons to the model. That's very important in computer graphics to enhance realism and improve performance. In the same way, let's add a roughness map. Switch the color space to non-color, because the roughness maps are black and white data. Black and gray parts are smoother and more reflective. White parts are rougher. We can also add all textures in a practical way with Node Wrangler add-on. Ensure that Node Wrangler add-on is enabled. Select the Principled Shader, press Shift-Control-T, and select the Diffuse, Normal, and Roughness maps. Click the Principled Texture Setup button. That's it. Let's add a monkey head. Press Ctrl+3 to add a subdivision surface modifier. Right-click and make Shade Smooth. Switch the Render Preview mode. Click the New button to add material. Pick a skin color. Open up the Subsurface panel. Subsurface Scattering is used to render materials such as skin, milk, and wax. Light scatters below the surface to create a soft appearance. Let's increase the weight value to 1. It blends between diffuse surface and subsurface scattering. The radius value is the average distance that light scatters below the surface. A higher radius gives a softer appearance, as light bleeds into shadows and through the object. There are 3 color channels here. The X, Y, and Z values are mapped to the R, G, and B values respectively. Let's increase the red channel. In this case, the light scatters under the surface as reddish. If you increase the green channel, it scatters greenish. If you increase the blue channel, it scatters bluish. The rendering method is used to simulate the subsurface scattering. Christensen-Burley is an approximation to physically based volume scattering. This method is less accurate than random walk, however, in some situations, this method will resolve noise faster. Random walk provides accurate results for thin and curved objects. Random walk uses true volumetric scattering inside the mesh, which means that it works best for closed meshes. Overlapping faces and holes in the mesh can cause problems. It works only with the Cycles render engine. The random walk skin method is optimized for skin rendering. The radius is automatically adjusted based on the color texture. Delete the monkey head and select the sphere. Delete all texture maps. Pick a blue base color. Open up the Specular panel. The Specular panel controls the intensity of the specular reflection. Specular reflection is the mirror-like reflection of light from a surface. In diffuse reflection, light is scattered in many directions. Specular reflection occurs when light bounces off a surface in a single direction. We can control the specular intensity by changing the IOR level from 0 to 1. To better see the specular effect, lower the roughness value. If you set the IOR level to 0, the material becomes completely rough. This is a diffuse reflection and light is scattered in many directions. If you set the IOR level to 1, the material becomes completely reflective. This is a specular reflection and light is scattered in a single direction. tint input controls the color tone of the specular reflection. You can pick any color. Anisotropy in specular reflection refers to the directional variation of reflections on a surface. Unlike isotropic surfaces, where reflections are uniform in all directions, anisotropic surfaces reflect light differently depending on the direction. This creates effects like brushed metal or hair, where the reflection stretches and varies along specific directions. Let's import a cup model into Blender. Select the cup and add a new material. Rename the material as glass. Open up the transmission panel. Transmission is used to render materials like glass and liquids, where the surface both reflects light and transmits it into the interior of the object. Set the weight value to 1. It makes a fully opaque surface at 0 and fully transmissive at 1. Set the roughness value to 0 to make a smooth face. You can search for IOR value for glass on the web. That's it. You can watch my tutorial on how to make glass material in Blender Cycles and Eevee. Select the plate and assign the glass material. Let's make a fluid simulation quickly. You can watch my tutorial on how to make fluid simulations in Blender. Select the liquid and add a new material. Set the roughness value to 0. Set the IOR value to 1.333 for water. Open up the transmission panel and set the weight value to 1. That's it. You can also change the liquid color. Let's select the sphere again. Open up the coat panel. The coat parameter is used to add a clear coat layer over the material. This can be particularly useful for creating effects like car paint and lacquer. The weight slider ranges from 0 to 1. A value of 0 means no clear coat is applied. A value of 1 means a full clear coat is applied. The roughness controls the roughness of the clear coat layer. Lower values produce a shinier, more mirror-like finish. Higher values create a more diffuse, less reflective clear coat. You can control what part will be applied clear coating using textures. IOR affects how much the light bends when passing through the clear coat layer. Different clear coat materials might have different IOR values, but for most purposes, the default value is appropriate. Tint input adds a colored tint to the coating layer by modeling absorption in the layer. Normal input allows you to use a normal map specifically for the clear coat layer. This can be useful for adding fine details or surface imperfections to the clear coat without affecting the underlying material. All right, let's add a plane. Scale up the plane and move up. Tab key to switch to edit mode. Right-click and subdivide the plane. Go to the Physics Properties tab and add a cloth modifier for the plane. You can watch the tutorial on how to make a cloth simulation. Right-click and make Shade Smooth. Add a subdivision surface modifier. Switch to Render Preview mode and add a material. Pick a base color. Open up the Sheen panel. Sheen is used to simulate the effect of fabric-like materials, such as velvet or satin. For cloth, this adds a soft velvet-like reflection near the edges. It can also be used to simulate dust on arbitrary materials. The weight controls the intensity of the sheen layer. A value of 0 means no sheen effect is applied. A value of 1 means the maximum sheen effect is applied. The roughness value controls the roughness of the sheen reflection. The tint controls the color of the sheen reflection. Emission is used to make the material emit light, effectively turning it into a light source. This parameter is useful for creating materials that need to appear self-illuminating, such as screens, light bulbs, and glowing objects. Thanks for watching. See you in the next tutorial.